Continuing the examples of probability distributions for statistical inference, we're going to continue using the SMAS2D file that we were using, but now we're going to work with the chi-square distribution. Unlike the normal, standard normal, or the student t, it is not symmetric about 0. It's actually only defined for positive values of the random variable chi-square. And depending on the degrees of freedom, the curve is going to have different shapes. But the generic shape is this one shown in here. And so we use that to illustrate our particular critical values. When we have a value that the probability to the left is equal to alpha, remember alpha is the confidence, the significance level, we call that value chi-square sub 1 minus alpha. If we have one value whose area to the right is equal to alpha, that means the probability for that significant level, we have chi-square sub alpha. If we split alpha over 2 in the lower side and the upper side of the distribution, we're going to have two different values. Chi-square 1 minus alpha is the one whose probability to the left is alpha over 2. And chi-square sub alpha over 2 is the one whose probability distribution to the right, the area is equal to alpha over 2. We are talking about probabilities given for, like this case, for this first critical value, this expression for this critical value, and then this and this expression for the two critical values presented in the third place of the two-sided situation. And so, to obtain the one-sided lower tail, this one right here, I'm going to use this. Chi-square 1 minus alpha is the inverse cumulative distribution of the chi-square for alpha and the degrees of freedom nu. Chi-square sub alpha given by this expression, and then the two values in here given by this expression for the left one and this one for the right one. Specifically, for 12 degrees of freedom and alpha 0.10, we're going to use this equation that we presented here. Here they are calculated specifically. I'm using like this 1 underside alpha to indicate 1 minus alpha. And I'm getting this value for chi-square, which will be this value here to the left. And chi-square sub alpha would be this value for alpha equal 0.10. Chi-square 1 minus alpha over 2 will be the left value here. And chi-square sub alpha over 2 will be this one right here. And so I'm getting those four particular values for this case. These are typed separately. So if I change this to 0.05, these values are going to change, but not this. So let me just show you here 0.05. And you can see the values have changed, but not this case. This was just copied from the left. And this actually corresponds to 0.10. But you can borrow these formulas to obtain your corresponding chi-square parameters for the critical values. The F distribution is for the ratio of two variances, and therefore has two different degrees of freedom, the numerator and the denominator. For different combinations here, I'm showing you the general shape is very similar to the chi-square. It's non-symmetric about 0. It's only for positive values of the random variable, and it has that shape. And so the critical values that we get for the F distribution are going to be similar to the ones in the shape of the graph and the location of those critical values, similar to the case of the chi-square. We're going to have the F sub 1 minus alpha indicated by the first position there, F sub alpha indicated to the area to the right is equal to alpha, and then two values, F1 minus alpha over 2 and F sub alpha over 2, corresponding to these probabilities. These are the formulas to use to obtain those particular values using the inverse cumulative distribution function of the F distribution with degrees of freedom numerator and degrees of freedom denominator as used in here. And so let's say that we use our critical value, our significance level of 0.10 corresponding to a level of confidence equal to 90%. and we have degrees of freedom of the numerator 12, degrees of freedom of the denominator 22. These are the formulas that we're going to use to obtain those particular values, which get interpreted like this. So F1 minus alpha, we use alpha and the probability location here. F sub alpha, we use 1 minus alpha and the probability. And then for the two-sided case, we have two positions, F1, so 1 minus alpha over 2, we use alpha over 2 as the probability. And F sub alpha over 2, we use 1 minus alpha over 2 as the probability in there. And we obtain the corresponding critical values. With these two examples, then, we conclude this particular video about examples of finding critical values for the probabilities distribution for statistical inference.